to transform n to an, okay, for given sequence of f of n, then retain the sample you can say sample value at n equals to 0, whether a is greater than 0 or a is less than, I mean, a is greater than 1 or a is less than 1. At n equals to 0, it will be retained. There is no change as we have already observed. And 0 padding will be there in case of, this is the general, both for both the case. So that's why I have given as a statement. And zero padding will be there if a is less than 1. If a is less than 1, then 0 padding in the sequence at every interval of time with number of 0 equals to a minus 1. And when a is greater than 1, then decimation. That is loss of signal. Enough for this topic. I'll give you as a question, but it's okay, not required. They won't ask much more than that. If you are clear up to here, then we can end this topic. I'll now discuss about u of n. What happens? Suppose we will have to observe in case of, we have not discussed u of n, we have discussed u of t. So to understand this u of n, it is like uh, so this is like here. Simple concept it is. So u of n is equals to 1 for n is greater than or equals to 0, and 0 for n is less than 0. And it can be written as 1 comma 1 comma 1 comma and so on with the arrow mark here where n is equals to 0. And this is called u of n. Okay. So this is u of n. Now, if I write u of n minus 1, similarly, someone pinged me? No, I got two chats. Wait. Thank you. So it will be like shifted version from n equals to 1, right? Solve value 1, 2, and 3. For this, all you know already. And similarly, u of n plus 1, right? So what you have observed here, why I have drag you on the same topic, because we have some observation here, like if there is a, in case u of n, okay, I'll write first here u of n plus 1. So u of n plus 1 will be from minus 1, right? Minus 1, 0, 1, 2 and 3. तो अभी क्या है कि अगर हम लोग जैसे नाउ इफ वी विल हैव टू मेक डिफरेंस बिटवीन दिस टू सिग्नल्स, देन वी विल गेट u of n minus n naught means what you have observed. It is nothing but a sample value change, correct? At n equals to n naught. So n equals to 1, the sample value is changed from 0 to 1. Similarly, here it is 1, 1, 2, and 3, 4, and 5, 0. At n minus 0, at 0, it is sample value is changed. N plus 1 means minus 1, sample value is changed to from 0 to 1. Earlier it was 0 and this to 1. And so we can write it here like, suppose we can give another example. Give me a second. Yeah. I want to finish this topic today itself. Today we have to go up to convolution. So minus 2, minus 1. So this is minus 2, 0. And 0. Suppose I'm having a value of t2. Okay. Now at 1, this is minus 1. This is 1. And at 2, it is 3. Suppose. So 3. So you what we can write it here as u of n is equals to sample change at n equals to n naught. So for u of n plus 2, correct? Because the sample value is 4 is changed from 0 for n u of n plus 2. Now sample value is changed from 4 to minus 2, so minus 6. If you want me to skip this topic, I can skip this because this discrete form I have not taught you. We have not discussed the discrete form, no? Anyone? So I'm just writing it. The same concept is heading here. I don't think you will get any confusion. If confusion is there, then please let me know. I'll explain it. Okay. 2 plus 2, then minus 1, minus 3, minus 1 to minus 2, minus 3, right? Minus 3 u of n minus 1, then 3 minus 1 plus 4 u of n minus 2. So after that, now it is turning to 0. So minus 3 u of n minus 2. Correct? If you will observe 4 minus 6 plus 4, 8 minus 6 minus 2, 4, 4, 4, 8, 12, and 12. Sum of coefficient of, again here also, coefficient of, sum of coefficient is equals to 4 minus 6 plus 4 minus 3 plus 4 minus 3 is equals to 0. These things we have already discussed in the continuous time domain. Am I right? Now for del of n, now I will discuss. Please stop me if anyone is having doubt here, because this is a repetition and I want to move it fast forward. The same concept in case of discrete time signal, and I cannot skip this like continuous time we had done, so we have to do discrete also. So this is del of n, which is equals to 1. See, in case of del of t was infinity, at t is equals to 0, or we can say del of t is not equals to 0 at t is equals to 0. But here del of n is equals to 1 at n is equals to 0, and is equals to 0 for n not equals to 0. Is this clear? This is point to be noted. In case of time domain signal, del of t at t is equals to 0 is infinite. Del of n is equals to 1 at n equals to 0. Okay. Similarly, here, like plus 1, and this is 1. So this is del of n minus 1. Similarly, we have del of n plus 1. This one, if it is written here, 1, this is 1. Actually, this amplitude is not mentioned in this del function. We don't represent here. This is the area actually we consider. So we have to write here as 1, and this is also 1. So this red color is del of n plus 1. Everyone knows this, correct? So now a point is, we have an example like here. Okay, in the next page we will do. Please stop me if I go faster, or if you can't write, I'll stop there itself. If you are not saying anything, I will understand that everything is fine, because I don't want to waste the time for those, not for those, for everyone. Minus 2 with the area 2, with the area 2, 0 with the area 3, with take it here as 1 also, with the area minus 3, 0, area 3, 1, and this one has 4. Okay, and this can be, now focus here, f of n can be written as 2 del of n plus 2, correct? 2 del of n plus 2 minus, there is no concept of area change. It is the area here, minus 3. Directly we will write minus 3 del of n plus 1, because here this one is 1. Okay, plus 3 del of n minus this one, 2 del of n, n minus 1. Now this one plus 4 del of n minus 2. Right. Now focus here. This is f of 2. Am I right? So this is nothing but f of 2 at del of n plus 2. This is nothing but f of minus 2 rather. So, wait. Is this f of minus 2? This is f of minus 1. This is f of minus 1. Is this f of 0? Again, this is f of 2, f of 1, sorry, f of 1. And is this f of 2? So can we write f of n is equals to f of minus 2 del of n plus 2 minus 3 del of this one? Anyone is following me or just listening to me? Please tell me. Because now I am moving towards a little complicated part. Ritika, Tarun, Vignesh, Vijayalakshmi, Yamini, Bharat, Bharata. I'm sorry if I pronounce in the wrong way. Hema, following.
Yes, sir. Following.
Thanks, Vijayalakshmi. And who responded? Okay. So now we can write like f of n like f of minus 2 as k. I'll write like this. Just focus. F of k del of a minus k, a value 1 minus infinity to infinity. Please observe this equation which I have moved from here to here. This is very important equation. It will help you out in integration of un del n relationship convolution also. Is this clear? Nothing. Just put the value of k. K value is minus 2. F of minus 2 del of n plus 2. Take the k value as plus 1. I mean, yeah, f of plus 1, the f of 1, like here, f of 1, del of n minus 1. Del of n minus 1. I'm not giving the area value. It is a general f of functions, right? One more thing. Just now we had observed here. Here I told now why have I dragged you here? Why had I dragged you here for again the same concept? We can write like 4u of n plus 2 minus 6u of n plus 1 with these samples, correct? You remember this? Can I write this also in the same fashion? Like f of n is equals to 2u of n plus 2, step change of minus 3 to 2. In terms of unit step function we are writing, not in terms of delta. So it is now minus 5. U of n plus 1. 3 minus of minus 3. 6. Minus 6. U of n. Yeah. Now for this, minus 2, minus 3, minus 5. U of n at n equals to 1. Now this. For minus of minus 2, 6. U of n at 2. And then this is turning to 0. So minus 4 u of n minus 2. Okay. Overall, we can, this is also u of n minus 2 and this is also u minus 2. We can write 6 u of n minus 2 minus 4 u of n minus 2 is 6 minus 4 is 2. 2 u of n minus 2. You can combine in a, because here we write, after this we have reduced it. You can directly add it. 6 minus 4 is 2. Not a problem. Okay. So now what here we can say again here, like, first of all, I have used this del function. Don't get confused. With a del function, I have used f of 2, okay, f of n values. Then I am using with the step function, okay. So this is 2 value is nothing but f of minus 2. Again, same thing. This is f of minus 2, and this one is not f. This is not f of minus 2. Actually, it is the step change. So this is minus 3 minus 2. This is not of f of minus 2. This is not f of minus 2. This is the step change actually. Fine. So here what we have observed that this is the functions in case of del minus 2. You should have to observe that we are having a value of f at different value of n, and we are integrating del of n to get integrating with del of n. I mean to say, impulse function is integrated with f of n, yani ki, signal to get the complete signal figure. Okay. I have one thing. U of n I still and u of n minus 1, right? Uh, one second, we have discussed here. Not del of n, del of n plus 1, then this one. Hmm. So now I wanted to draw it like u is equals to minus infinity c plus infinity. This f of k, this f of k can be written as u of k. Can I write this as u of k? Tell me. Because this is nothing but a step function kind of. See here, with a here the way I have here mentioned 2u of n plus 2 minus 5u of n plus 1. So this function can be written as u of k del of n minus k. Is this clear or not? First let me know. Sorry. Is this clear? I'm seeing the chat. Bharat, Hema, Ritika, Tarun, Vignesh, Vijayalakshmi, Yamini. It's 5 o'clock. Oh my god. Please respond. I only replace the f of n as u of n. So f of k will be u of k del of n minus k. Up to here, is this clear? Okay, I consider it as you have understood. Since u of k runs from like u of k runs from k greater than or equals to 0 and 0 is for k less than 0. So we can write u of n as k is equals to 0 to infinity. U of k is 1. Okay, so we can write it as del of n minus k. So this is the formula we have find, and the relationship between, like in case of continuous time domain, we had u of t integrate u of t is equals to del of t dt, right? From minus infinity to t, correct? Similarly, analogy in discrete time case, we have u of n summation of k from 0 to infinity to del of n minus k. How it is derived? I showed you with a signal f of n, and the signal's value I have demonstrated with the values and just illustrated with this. We can write this in an expression, and in a general fashion we can write f of k del of n minus k, correct? Since I am deriving from for u of n, so replace f of n with u of n, and so f of k with u of k, then del of n minus k. So since u of k is equals to 1, we are not, we can ignore it to mention here, and we can directly write del of n minus k u of n. Here what I am trying to say here, like if I am writing the terms of u of n, then this will be a step change instead of, this is also a step change. And here it is not a step change, it is a area. I mean, the value of that function at particular time, n equals to minus 2. So I was just comparing within these two. Please let me know if you are understanding this. It's a very simple concept. Hema, Ritika, Tharun, Vignesh, Vijay Lakshmi, Yamini. Is it going smoother? Bharat? Bharat? Yes. It is Bharat Shritha. Bharat Shritha. Shritha. Okay.
Shrita, sir, you can call me Shrita.
Shritha. So are you understanding?
Yes, sir.
So likewise, we have del of t is equals to d by dt u of t, if you remember. Here, since here it is an integration, so here will be u of n minus of u of n minus 1 for del of n. Simple. And you can draw this also and subtract it, you will find this value. It's not a big deal. Okay. Now, I hope you understood this. So now you can write u of n as, no, not like this. You can write this like del of 0 plus del of n minus 1 plus del of n minus 2 plus del of n minus 3 plus so on till infinity. Correct? U of n is like that only. If you will draw the sketch, then you will understand this. This is u of n and so on. Correct? And we can write this u of n as summation of del of k for k running from 0, not 0, actually it is going towards, k is positive, right? It can be 0 to infinity, from 0 to, नहीं तब तो यहाँ पे n by, then it will be n by k. I am telling about the k. So I am replacing this with k. Then here it will be minus infinity to n. Is this expression is clear? There are two expressions, u of n is equals to 0 to infinity, right? Nothing. I have written n minus k as minus infinity in this case, and I just replace the value till n. Okay, so it will give the value of u of n till the value of n. So it should start with. That's why you make it confused. Let's start with here del of n. So keep the value del of n, that del of n minus 1. It should start with m. Then I think you can understand properly. If you will keep del of k value as n, del of n, okay. K value as n minus 1, then del of n minus 1, okay. K value n minus 2, del of n minus 2, okay. Till minus infinity. Okay. So this summation will also result u of n, and this summation will also result u of n, and I have explained in both the way here. How it is derived? I have just taken an example and considering this as u of k function. I mean, I have just used this signal, replace the sample signal with, if it is any general signal, then I have replaced with step function and then derive the signal u of n from del of n. In the next case, I have just expanded del of n and summation. Just showed you how it is minus infinity to n, del of k is u of n. So in case of discrete time, we have del of n is equals to u of n minus u of n minus 1. And continuous time, it is del of t is equals to dy t u of t. This you have understood. That means difference becomes differentiation. I mean, difference in discrete time will become differentiation. Everyone knows this. It's a general concept. Differentiation in continuous time. Summation will become integration here. Simple. Try for R of n. That's not an issue. I just want to start even and odd signals. Anyone is ready for that? So discrete and continuous time is over. Anyone is having doubt here till now? Any doubt? Please let me know. Vijay Lakshmi, Vignesh. Vignesh, you are coming here first time. If you are okay with this class, let me know.
Yes, sir.
Are you feeling good
Yes, sir.
or stuck? Okay. Hema is driving. Hema is not available. Shritha. Shritha.
Yes, sir.
Okay. Vignesh, Vijay Lakshmi, Tarun. Okay. Then okay. Even an odd signal. I know everyone is looking for gap interval, I think. Sorry, I cannot give interval now. Half an hour is left. What you are interested in? No response means I will continue. Oh, 6 chat. Okay, Ritika, thank you. Reduction. So now, even an odd signal, we have one signal like this. Take any signal which is symmetrical. Take this part and take this part. This is f of t. With t minus 1 to 1 with origin as 0. Now, if you will do f of minus t means time reversal. Already you know time reversal property we have done. So t f of minus t So this will go this side and this will go this side. That means this is second and this is first. With this one is 0, minus 1 and 1. So this is f of t is exactly equals to f of minus t. So this one is an even. I assume there is no doubt over here. Take another example of the signal. Take f1 of t and draw a signal like here. Okay. Minus 1, 0, 1. And this is 1, minus 1. Now do time reversal for this f of minus t. While time reversal means y-axis mirror image. Draw the mirror image about y-axis. I assume there is no confusion. If it is, please let me know without hesitation. Okay. So this will here and this will be here. Correct? So this is 1, minus 1, 0, minus 1 and 1. This is f of minus t, f1, sorry. Fine. Do about the x-axis mirror image means minus f of minus t. Okay. So about this x-axis, draw this. So this part will go upside and this part will go downside. I'll draw here. Right. First, this one is 1. This one is 2. Correct. Now y-axis. So this one is 1. This one is 2. Now about x-axis. So this will go here and this will go here with 2 as here and 1 is here. And this one is, this signal is minus of f1 of minus t. Minus 1, 0, 1, minus 1 and 1. So now can you observe it? So this is called f of t is equals to minus of f of minus t. And this is odd signal. This is even and this is odd. All right. Here. Going to the next page. Now suppose this is a signal. Which is having signal like this. With 0 here, minus 1 and 2. With 2, 1. Okay. Is this odd or even? It is non-symmetric. Neither even nor odd. Right. Now, do the time time reversal of this. I'm sorry. So this space will be, I will adjust this, not a problem. I will do this from here to here. In the same ratio I want to keep it. So this is the time reversal. -2 with f of minus t. This is t and the amplitude will remain as 1. Now add both the signal. Up to here, I'll do one thing. Yeah. So up to here is okay. If you will add, it's an arithmetic addition. No rocket science here. -2, it will go up till value 1 because here it is 0 till 1, right? Arithmetically addition. The value is 1 plus 0 is 1. So up to here it is 1. So here it is 1, here also 1. It will jump to 1 plus 1, 2. This 2 will be till 1. I'll first write access completion -1, 2. Meanwhile, if I'm doing some corrections, you complete your signal draw. If you can do it by your own, on the same color, man. -1, 0, 1, and 2. This is -1, 0, 1, and 2. Okay. So here, up to here it is okay. So it is 1 and this is also 1. So 1 plus 1, it will jump to 2 once only. Up to here 2. Okay. From here to initial point it is 2, right? So there is a jump of only one step from here to it. If we'll go from -1 onward on the time axis of -1, then the amplitude of 1 and 1 get added. Okay, no problem. Up to here, it will go in the similar way. Up to here, it will go in the similar way, right? So now it is now 0 here, and here it is 1. So it is moved to some. I don't know how to adjust this. Are you able to see? Then it's okay. I will not bother. So if 1 to 1, then it is okay. After that, it is only 1. Here it is 0. So 1 plus 0 is 1 only. So this will deteriorate to 1, decrease to 1. It will run up to here too. Correct? Then it will, from here it is 0 only, and it is reducing to 0 value. So 0 plus 0, it will be here at 0. So can you observe this? This is a signal which is even. This is even signal. F of t plus f of minus t is done here, which is g of t I can consider, and this one is even signal. Any doubt in this, please let me know. Then only I can move forward. And my screen is moved. I don't know how to fix this. See, I'll do control. I don't care. Yeah, I'm just seeing the chat. Please respond. All clear? Can I move to the next part? Shridha, Hema, Ritika, Tarun, Vignesh. Vijayalakshmi, Yamini, please tell me. Got a message from Hema. Okay, sir. Thank you. And Shweta also, thank you. Vijayalakshmi, thank you. Okay. I need a response faster so that I can move easily. Yeah, thank you, Ritika. I hope no doubt here because it's a simple concept. So now, keeping the signal again here same, if I subtract it, first addition, getting an even signal. Now add on. If I subtract f of t, what was f of t here? F of t was this one, correct? Then f of minus t, f of minus t. Now do f of t minus of f of minus. So here this is 0 and this is 1. 0 minus 1 is minus 1. Till I'll first draw this one, the demarcation line, the axis. This is minus 1, this is 0, this is 1, this is 1, this is minus 2. Okay, so here it is 0. 0 minus 1 is minus 1, so it will move down till here. Then 1 minus 1 is 0. This is 0, 0, 0, 0, 0 up to here. Then 1 minus 0 is 1 till here. So this is 1 and this one is minus 1. But you can say it is an odd signal, you can check. One remarkable point is, in case of odd signal, every time you will see that at time t is equals to 0, it will be 0 only. Suppose we have taken the sine function. So sine function at time t is equals to 0, it is an odd function. So at time t is equals to 0, it will be 0. Similarly here, this is at t is equals to 0, it is 0. Similarly here, at time t is equals to 0, it will be like 1 minus 1 is 0 only. It will be like this only. So 1 minus 1, yeah, you can consider it as an average of, it is 0 only. So it happens in case of most of the time you will observe that an odd type signal, it will be 0 at time t is equals to 0. Okay. So this is all about this, even an odd signal, and we can say that maybe next we can say that